Hello and welcome to Project 152, your weekly specialist exam prep. Now, every week we go through questions that the QCAA has released. If you stick with us for the whole time, you'll have done all 152 questions that the QCAA has ever done. This week is week 27, and let's get stuck into it. First question here, and I like this question because there is so much useless information here. So much. So what's going on? The time taken to complete a pizza order is normally distributed with a mean of 10 minutes. The owner of the pizza store records the time taken to complete orders for a random sample of 20 pizzas each day over a 30-day period. From this data, an approximate 90% confidence interval for the mean is calculated at the end of each day. How many of these confidence intervals would be expected to contain the mean? Okay, what do I mean there's so much useless information? Well, the time taken to complete orders, 10 minutes. Useless, we're not going to use it for this question. The owner of the pizza store recorded the time taken to complete orders for a random sample of 20 pizzas. Okay, again, that is useless information. Each day over a 30-day period. That's actually the information we need. So they're taking samples, 30 samples. They've taken 30 samples. And for each of those 30 samples, they've taken a 90% confidence interval. So what does a 90% confidence interval mean? It means that if you take that sample over and over and over again, 90% of the samples you take will include the mean. So to answer this question, we're just finding 90% of 30. 90% of 30 because there's 30 samples and 90% of them will contain the mean. The other 10% won't contain the mean. So what's 90% of 30? It is 27. The answer is C. Celebrate. All right, I like this question because it's probably the best picture that the QCAA has put out. So what do we have? We've got someone skydiving and they weigh 85 kilograms. So let's put a pin in that bit for a second. When the magnitude of the air resistance is 62 newtons. Okay, so we know that the air resistance here is 62 newtons. Now what about the force acting downwards? Well, we know force equals mass times acceleration. And we know that this person weighs 85 kilograms and they're being accelerated by gravity, 9.8. Now, because this is acting in a downward direction, let's turn this into a negative 9.8. All right, let's type that into our calculator and we'll know how much force is acting downwards. All right, so my calculator tells me that the force acting downwards is 833. I guess we can say that that's a negative force. All right, so negative 833 down, 62 up. Now, the net force is just going to be whatever that is. Let's add those two values together. So I get a net force of negative 771 newtons. Now, there's no real need to talk about negatives and positives here because we're just looking for the magnitude of the acceleration. So we'll just go 771 newtons. All right, so how are we going to calculate that acceleration? Now that we know that the net force equals mass times acceleration. So now that we know that the net force is 771, and the person's weight is still 85 kilograms, we can calculate what their acceleration is. So acceleration is 771 divided by 85. Let's calculate that. The acceleration is equal to 9.07, and we can see that answer there. Stop and think for a moment about what all of this means and check to see if it makes sense. This person is falling down. Now, when you fall, gravity accelerates you at 9.8 meters per second. But there is air resistance in play here. So the air resistance will slow you down. Your acceleration will no longer be 9.8 meters per second. It'll be less than that. How much less than that? Well, not that much less than that. So 9.07 makes a lot of sense. So even if you didn't do all of this calculation, an answer that you could definitely discount would be D. The air resistance isn't speeding this person's acceleration up, so D would get discounted. And C, feels right because you've seen objects falling out of the sky with some wind resistance. So 9.07 just makes a lot of sense. Done. So here we have a monster of a question. It's from the notoriously difficult 2020 exam. 9 marks in total, 4 parts. Quite intimidating. So let's just go with part A. Now the exam writers have tried here to make it easy, but because there's so many words and so many equations, so much going on, it's a little bit scary, but it really shouldn't be because it's pretty straightforward. All right, so what do we have? We've got some sort of experiment and we've got some differential equation here. And then they say, given this bit of information, this equation here, this is equal to that, show that the general solution of the differential equation can be expressed as this. All right, so basically they're just asking us to solve this differential equation, and they're giving us this because they think it will help us. So let me write down this differential equation. Now, when you write this differential equation, it should be clear that something funny is going on because this dn dt and then this equation is in terms of n. So think about all the work that you do in methods. You're used to being dy dx and then this equation being in terms of x. So the thing on the bottom is what our function should be in terms of, but it's not the case here. So what we can do is flip this entire equation around. So it's dn dt there. Sorry, I meant to say dt dn there. And then look at this. We've got an 1 over 1000 times n 1000 minus n. Now this is equal to, and I'll just rewrite it over here, it's equal to n 1000 minus n over 1000. So flipping this side, we also flip this side, we end up with 1000 over n 1000 minus n. Okay, that's really good. I'll just get rid of that. Now here's where the exam writers have tried to help us here because they've said, given 1000 over n times 1000 minus n, given this is equal to this. So that must be useful information. So without even thinking about it, I'm going to rewrite that as that because they're telling me it's important. Now, if dt dn is equal to this, then t will be equal to the integral of that with respect to n. And then from here, using our integral rules, we've got 1 on n, which is ln n. And then we have the integral of this, and you need to be a little bit careful because it's got this negative n here. So the integral of that is going to be equal to negative ln 1000 minus n. And then, of course, I'm going to have a nice little plus c here. All right, I'm getting pretty close. Look at what the question says. Show that the general solution of the differential equation can be expressed as this. I'm close because I've got like this thing here. What are my problems? Well, I should have a t and a c on one side. So I can just move this plus c over to here. And believe it or not, I can write it as a plus c as well because c is entirely arbitrary. So it's not like when I move a plus c from this side to this side, it becomes negative c. I can still write it as plus c. Okay, what else do I have? Oh, I have 2 logs, and I can use my log laws here to combine them. A log minus a log, that's going to be ln log 1000 minus n. I think I'm done. Yep. T plus c, ln n over 1000 minus n. That's what this is. It's just with the t plus c written around the other way, but it's exactly the same deal. I'll give myself 2 marks for that and a quick little celebration. Let's take a look at the part B. I don't think we need any of this for part B, so we can just keep moving forward. All right, so part B says, a scientist commenced an experiment at 9 a.m., observed 100 yeast cells, show that the solution of the differential equation can be expressed thusly. Okay, so even if I couldn't do part A entirely, it's fine because I've actually been told that the general solution is this, And you can use that general solution plus this bit of information about 9 AM and 100 yeast cells to calculate this. And so that's what I'm going to do. I'm going to write this down first of all. All right, so there's my starting point, and I'm told that an experiment started at 9 AM. Now you need to be careful here because the experiment started at 9 AM, but T doesn't mean like time of the day. T means T hours in a test tube. So if the experiment started at 9 AM, it has been in the test tube for 0 hours at that point. So at T equals 0, we can see that our number of yeast cells, N, is equal to 100. So all I need to do now is sub T equals 0 and N equals 100 in there and figure out what C is equal to. Okay, so this is looking okay. Now, if I simplify this, it's 100 over 900, which is 1 over 9, and 0 plus C is just C. So I'm going to end up with ln 1 over 9 equals C. All right, so now I have a C value here, which means that I can sub this C value, ln 1 on 9, into my original equation. So let me just put this in for C. I'm going to do it up here. All right, so that's put in there with my new C value. Now, this is where I'm aiming. I'm aiming at no logs at all. I'm just aiming at this thing here. And so if I'm aiming for no logs at all, probably best to get rid of the logs by rewriting this in exponential form. So we've got a little e here. So writing this in exponential form, I'll get e to the power of all of this, t plus ln 1 over 9 equals this, n 1000 minus n. Now this might feel like a funny little move to some of us, but the trick here is understanding that when we've got this e here, we can rewrite this as e to the t times e to the ln 1 over 9. And then this e to the ln, e to the natural log, that's something that should make alarm bells happen both in methods and in specialist, because that's equal to just 1 over 9. That e and that raising to the power of ln, they cancel each other out, and we're left with 1 over 9 here. N 1000 minus n. And really, it feels like we're about done here. We're trying to get to n equals something. So e to the t times 1 over 9, that's just e to the t over 9. Now just rearrange this a little bit, bring the 1000 minus n to this side, 1000 minus n, and multiply both of those by e to the t, and then bring this 9 up here, so 9n. Expanding this, 1000 e to the t minus n e to the t equals 9n. I can move this n over here now, so 9n plus n e to the t equals 1000 e to the t. So then grouping these n's, I'll get an n here, 9 plus e to the t. Okay, and then that means that n is going to be equal to 1000 e to the t over 9 plus e to the t. Okay, that feels like a problem though, because I've got n equals 1000 e to the t over 9 plus e to the t, and they've got 1000 over 1 plus 9 e to the negative t. So I've got 2 e to the t's here, they've only got 1, but mine are both positive, theirs is negative. If I want an e to the negative t on the bottom, I should be able to get it just by multiplying top and bottom by e to the negative t. All right, so let's just see what happens when I do that. 1000 e to the t times e to the negative t. E to the negative t is just dividing by e to the t. So 1000 e to the t times divided by e to the t, we just end up with 1000 on the top. And then we're going to get 9 times e to the negative t, because we're going to have to multiply both of these by it. So that's going to give me 9e to the negative t. And then I get e to the t times e to the negative t, which is just 1. We're dividing by itself, right? So plus 1. Beautiful, because that is exactly where I was aiming. N equals 1000 over 1 plus 9e to the negative t. A little bit of working there to rearrange it. You could probably rearrange it a little bit faster by skipping out a line or two, but there we go. All right, celebrate that one. Next question coming up. So believe it or not, we're only up to part B, but part C is actually a much easier question. Determine the time of day when 900 yeast cells were present. Now, this question is designed so that if you couldn't do part A, if you couldn't do part B, you're still supposed to be able to do part C, because we know that this is an equation relating the number of yeast cells to time. So we can just sub 900 in here and solve for T. All right, so that's it. 900 is the number of yeast cells. There's my equation. I'm going to solve for T using my graphics calculator. And here's my calculator. I'm going to go option, calculate, solve, and then I'm going to type in that equation. All right, easy, straightforward. The letter X, not T here, and then execute that, and 4.39. So that's the value of T. Now we are asked for the time of day. So we started at 9 a.m. and it was 4.39 hours later that happened. Now it might just be a bit more exact here, 4.3944. So 4 hours and some decimal amount of hours. So let's find out how many minutes 3944 times 60. All right, so that translates to 23.664 minutes. I don't think I'm going to do seconds here. So I'm just going to say that it's 9 a.m. plus 4 hours and 24 minutes. And so when I calculate that, time of day, it'll be 1:24 p.m. That's when we'll have 900 yeast cells present. Okay, one more little piece of this puzzle. So the last part of this question is, the scientists predicted that the number of yeast cells would eventually exceed 1200. Evaluate the reasonableness of this scientist's prediction. Now, if you've seen it here, you'll know straight away what's going on and whether it's reasonable or not. If you're not familiar with this though, what I suggest is just graphing this and seeing what it looks like, because graphing this will tell you whether the yeast cells will eventually exceed 1200. All right, so there's my little graph. I'm going to execute that. Now, notice Y is N, the number of yeast cells, and X is the time. Let's draw it. We might do like a little zoom, like auto, see how that helps us. All right, you can see we're getting a nice little curve here. It looks like it's going to be a logistic curve. You can see that the yeast cells are not above 1200 in our picture. So we can do a little view window here, set our Y max to like, let's go with 1300. Oh no, let's go with 1200. And then let's go an X max, that's the time. Let's just make the time really large. That was 44. Let's go with like, I don't know, 2000. All right, and then let's execute that. And draw it. All right, and you can see we're getting this graph that levels off at 1000, and it never goes higher than 1000. Maybe I'll just change my view window, not so aggressive on the x-axis here. All right, still pretty aggressive, but you can see we've got that 1000. Let's go one more time, just with like a 100, and draw that. Okay, if we go across here, what we're getting is this ceiling of 1000 where this logistic curve never goes above. Why does this logistic curve never go above 1000? You can approach this question without a calculator using the concept of limits. As time gets very, 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 very large, this number here gets very, 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 very close to 0, which means that this 1000 divided by 1 plus 0, 1000 divided by 1, we approach 1000. So mathematically, we would say as t approaches infinity, n approaches 1000. So what about the scientists' prediction that the number of yeast cells would eventually exceed 1200? No good, no good. So given this equation, As t approaches infinity, n approaches 1,000. The number of yeast cells has a limit, as all logistic functions do. This limit is 1,000, so n will never reach 1,200. The scientist's prediction is not reasonable. That is that question, and what a big one. All right, celebrate next question. Now this question, by comparison, is going to be fairly straightforward, and it's question 17. Okay, the mass of populations is known to be normally distributed. The biologist randomly selects a number of elephants from this population. All right, so we don't know the number, we just know some number. Measures their masses. The mean mass is 5206, standard deviation 356. The biologist uses the data to calculate a 90% confidence interval, and we get this. This is our 90% confidence interval. Finally, we're going to determine a 99% confidence interval using the same data. So, I like this because it's one of those questions where you're finding something within a formula you maybe don't necessarily usually find. So here we have our confidence interval formula, and we know everything here except for n. All right, so let's go through each of these in turn. The mean mass of the sample is 5206. Okay, 5206, that's the mean. Subtract the z-score, 90% confidence interval, so we should know that that's 1.645. A standard deviation of 356. And we're dividing by, and this is the thing we don't know, we're dividing by n. Now, this formula will give us the lower bound of our confidence interval, and the lower bound of our confidence interval is 5159.1. Beautiful. I have an equation, I have an unknown, I have a graphics calculator, so I'm not going to bother trying to rearrange this calculator. I'm just going to ask my calculator what the answer is. So we're going option, calculate, solve n, and then we're just typing this equation in. All right, you can see I've typed it in, solve n, 5206 minus 1 times 356 root n 5159.1. It's worth noting that if you make a mistake here, it's broken, right? So you've got to double check when you do these things. Execute, and we get an answer, 155.91. Now, of course, it doesn't make any sense to have a sample size that is decimal. You can't choose 155.91 elephants, so we round to n equals 156. And you might be thinking, oh, is this one of those cases where you have to round down to 155? No, it's not one of those cases. It's probably just the case that they've rounded this to one decimal place. If they'd left it at 2 decimal places, our answer would be closer. This 155 would be 0.91 would be closer to 156 exactly. Okay, so now I know n equals 156. The next bit just says determine a 99% confidence interval for the population mean based on the same data. So do I have everything I need to do that? I think I do. I think this question's really done, right? Because I know the mean, 5206, because it says use the same data. Now, I'm not going to use 1.645. In fact, I don't think I'll use the formula at all because my calculator will be able to do this for me. I'm going to use the same standard deviation. I've got a sample size now, I've got 156, so then I'm going to be able, this is the thing I don't have, the lower bound. So now I just need to calculate the lower and upper bound, and I'm going to use my calculator to do it. Now I always get a little lost here, so let's see how we go. Statistics, and we are going to intervals, we're going Z intervals, and we are doing a 1 sample. So that's what we're doing in Specialist. You do the proportion one in Methods. So, confidence level, what do I want? I want a 99% confidence level, a standard deviation of 356, a mean mass of 5206, a sample size, which is what we calculated, 156, and I think we're done. We'll execute that, we get an answer. All right, so I've calculated a 99% confidence interval using my graphics calculator. I'm rounding to 1 decimal place because that's what theirs were, 1 decimal place. We get 2 answers, 5132.6 for our lower bound and 5279.4 for our upper bound. What a simple, straightforward question. As long as you can use that formula that I have hiding behind there. And as long as you can use your calculator pretty efficiently, very straightforward question 17. All right, let's celebrate and on to our last question for the day. All right, so a fun little question here. Something's getting dropped from a height. Okay, now the interesting part about this is that if you look at our acceleration, all right, so this is our acceleration, 9.8 minus 0.1 v. So it's acceleration in terms of velocity. So acceleration in terms of velocity, you should be looking at your formula sheet. So there's our formula sheet. Now, if you've got an acceleration in terms of velocity, you really want to be looking at this formula here, v dv dx. So that's when your acceleration is a function in terms of v. We're going to use v dv dx. So let's just write it out. All right, so far so good. v dv dx, 9.8 minus 0.1 v. Now, when we've got this pattern here, this v dv dx, we should be thinking about separation of variables, moving all the v's to one side and all the x's to the other side and integrating both sides. So I've got a v on this side and the dv on the top. So I'm going to move all the v's to where the dv is on the top. I've got the dx on the bottom here, so I'm going to move it to this side. Okay. Now this 9.8 minus 0.1 v, I'm going to move it to this side as division. Okay, and then I'm integrating both sides. And you might be thinking, well, I've got nothing to integrate here. I do, the number 1. All right, so that's pretty good. V over 9.8 minus 0.1 v, and then this one here. Now this side's going to be easy. Integrating 1, it's just x, and then I'll put a plus c on this side. It's this side that's really going to cause us some headache. Now there are a few different ways that you can attack this question, and you can look at the work solutions to see someone tackle it a different way to how I'm going to tackle it. But my basic idea is, because I have a v and I have a linear function in terms of v, I'm going to use linear substitution. But before I use linear substitution, I'm just going to get rid of all these decimals here just by multiplying top and bottom of the fraction by 10. It doesn't really affect much. It's just going to make working a little bit easier because I don't have to worry about the decimals anymore. So I'm going to end up with the integral of 10v over, instead of 9.8, 98, and instead of negative 0.1 v, just v. And because this is 10 times v over this, I can move that 10 out the front of the integral and get something much simpler to deal with. All right, so I have 10, the integral of v over 98 minus v. So now I'm just going to, and I'll do a little bit of like scratch work over here because they don't need to see absolutely everything I do. I'm going to let u equal 98 minus v. That's a v. And that means that the derivative of u with respect to v will be equal to negative 1. And that means that dv is going to be equal to negative du. Okay, so there's step 1, but also I'll rearrange this here. So if u equals 98 minus v, that means that v equals 98 minus u. Okay, now with all of this in play, this piece of information, this piece of information, and this piece of information, I can play with this a little bit. So we're still going to have 10. We're going to have the integral. V is not v anymore. It's 98 minus u over 98 minus v is just plain old u now. And dv is equal to negative du. Okay, I can move that negative out the front. So that will give me, and all of this is still equal to x plus c, by the way. Okay, I can move that negative out the front, that's negative 10, and we're still finding the integral of 98 minus u over u. Now I can split that into two separate fractions, so 98 over u minus u over u, and u over u is just 1, and we're integrating that with respect to u. So we're getting pretty close to being done now. We've got negative 10, and the integral of 98 over u is 98 ln u, And it's at this stage I'll say U is not U. U is actually 98 minus V. And then we're subtracting the integral of 1. Now the integral of 1 is U, but again, sorry, the integral of -1 is negative U, but again, U is not U. U is 98 minus V. So we're subtracting 98 minus V. And that's going to be equal to X plus C. All right, it looks like we're pretty close. I think I've missed a bracket here because all that's going to be multiplied. This is going to be multiplied by -10, and this is also going to be multiplied by -10. I don't need this anymore, so we'll get rid of that. So here's our answer, and I've just expanded this. Again, you have to be a little bit careful. -10 times 98, -980. -10 times -98 is positive 980, and -10 times negative V, this is tough. Negative V is positive V, times -10, -10V. All right, now I'm going to do something that might surprise you. I'm just going to like destroy this 980. And you might be thinking, hey, you can't just get rid of a number. But remember, this constant here is an arbitrary constant, right? It might be the number 10, it might be the number 20. Now, because it's an arbitrary constant, it could be any constant at all, I can roll this 980 into that C value here. So this equation can be simplified just a little bit by getting rid of that 980 entirely and just rolling it into the C value. Very nice. Now that we've got this equation, we want to know what this C value is, and all we need are some like conditions that we know about. Now we know that the thing was dropped from some unknown height. Now we can be a bit creative here, and we can make that height initial displacement 0. So we can take the place we're dropping it from our origin. So at displacement 0, when you drop an object, its initial velocity is also 0. So we can sub x equals 0 and v equals 0 into that. All right, and we get a C value of -980 ln 98, because that becomes a 0 here, so we're left with this. That's 0, and this is 0 as well. Very straightforward, and that's going to give us a single equation now with that C in there as well. All right, so now that I have a single equation, let me fix it up. I can use this to do whatever magic the question is asking of me. So now, what's the question asking? In order for the instrument sensors to activate, its speed as it hits the ocean surface must reach at least 20 meters per second. All right, so we're above the ocean. If we're too low and we drop, by the time we hit the ocean, it'll only be like 10 meters per second, right? So we really want to know how high do we need to be to hit the ocean at least a speed of 20 meters per second. So we're just solving for velocity 20. So let's solve for velocity 20. So I've typed that into my calculator, solve n, and I've typed the full thing out. Now, keep in mind, I didn't have to use these absolute value bits here, right? They're superfluous because 98 minus 20 is 78. So I don't need to use an absolute value because I know it's a positive value, 78. Similarly, 98 is just 98, so there's no point even writing those in there. So when I solved for velocity 20, I got displacement 23.69. Let's round it, 23.7. So interpreting this 23.7, our drone needs to be at least 23.7 meters above the ocean, dropped, and because at exactly that distance, it will reach a velocity of 20 meters per second. So the other bit is that if it hits with a speed above 50 meters per second, the sensors will be damaged. So we can just solve for v equals 50. Now again, solving this in my calculator, I get 199.5 if we round up. X equals 199.5 meters. All right, so that is essentially the end of the question. The drone's height must be between 23.7 meters and 199.5 meters if it's going to work. All right, that's worth celebrating. Fantastic. So that concludes another Project 152. This was week 27. We have 3 weeks left. Catch you in the next one, week 28.